professionals will talk about Python and predicting customer retention rate. I will kindly ask you to mute your mic so we can hear Semere clearly. And if you have any questions, please leave them in the chat and Semere will answer them after the presentation. Finally, I want to let you know that this meetup is recorded. Hope you enjoy this session.
Thank you.
Semere, you can start.
Okay, thank you, Japit, for the introduction. Hello, everyone. I am here today to present about Python and that Python, and also about logistic regression. So, logistic regression about machine learning at the same time. So, I will open my notebook. I will then introduce myself also with you. Then you can read it also at the same time. So, I will share my screen. So, can you see my screen?
Yes, we can see it.
Yes, you can see it, everyone. And also, I hope my voice is also can be heard well.
Yes.
Okay, thank you. Yeah, I'm starting. We will talk, as I told you, about logistic regression. So the table of contents are brief introduction about myself, and also we will see what is logistic regression, and also logistic regression applications. When should we use it? Building a model for customer churn, mathematical expression of logistic regression, what is sigmoid function and what does it do, logistic regression in code, about the dataset, data pre-processing and selection, modeling, and also evaluation. So these are the pointers that we're going to discover. So my name is Semere and my father name is Okbai. And my occupation, currently I am working as data science trainer by Dugur Only company. It is located in Rotterdam, Rotterdam, Netherlands. So my education is I am graduated from Bachelor of Science in Civil Engineering in 2012 from Eritrea Institute of Technology, and I followed also technical learning process towards part-time building management in Hogeschool Rotterdam in 2019. My working experience are data working with Python by Dugur Only company from January 2020 until now. I was also mathematics teacher from 2012 until the mid of 2014 in secondary school, that is in Eritrea. I followed also internship civil engineering in Gehelhoed Engineering Company, Netherlands in 2012. I speak 4 languages. Tigrinya is my mother language, and that's also not enough language. That's why I learned English. So English, Amharic, and also Netherlands. So I speak 4 languages. So this is all about me, and I am also living in Netherlands. So I am here for about 5 years in Netherlands. So I learned also the language. I have BTW niveau. I have studied BTW niveau. So we will today, according to the meetup arranged by our organizer Caroline. So I will present about logistic regression. First, let us define what is logistic regression. So logistic regression is a supervised machine learning technique for classifying records of a dataset based on the values of the input fields. That means logistic regression can classify like yes or no. We will see it. Logistic regression is analogous to linear regression that tries to predicate a categorical or discrete target field instead of a numeric one. So linear regression predicates a continuous value, but logistic regression predicates a categorical or discrete value, like yes or no, true or false. Logistic regression is a type of classification regression. So if you wanted to know the difference between linear regression and logistic regression, so in linear regression, as I told you, we predicate a continuous value, such as the house of a price. The house of a price is a number, so it is used to predicate for a house of price, linear regression. Also, blood pressure of a patient, or fuel consumption of a car. All the numerical values or continuous values are predicated by linear regression. But in logistic regression, we predicate a variable which is binary, such as yes or no, true or false, successful or not successful, pregnant or not pregnant, and so on. So all these things should be also coded as 0 or 1, and they are coded using a methods like like functions like get do me. So in logistic regression, independent variables should be continuous. So when you are working with logistic regression, your independent variables should be in continuous. Otherwise, if it is categorical or discrete values, they should be transformed to some continuous value using functions like get do me, like that. So logistic regression can be used for both binary classification and multi-class. So logistic regression is not only used for true or false, pregnant or not pregnant, not only for binary, but you can also use for multi-classes. So if you want to see how dataset looks like, for example, this is a dataset with features or independent variables like tenure, age, address, income, etc. So these independent features, they can be continuous or categorical variables. And the dependent variable is like churn, like yes or no, and it is categorical variable. So this picture can give you a good idea about the independent variable and dependent variable from a data set. So the picture can tell us as well also. So logistic regression applications. So when do we use the logistic regressions? When do we apply them? If you want to predicate the probability of a person having a heart attack within a specific period of time, based on age or sex or body, then you can predicate the probability of a person having a heart attack. Also, to predicate the chance of a mortality in an injured patient. Also, in marketing context, you can also predicate whether a customer is going to buy something or whether he's going to purchase a product or he will stop a product. So you can also apply logistic regression in such kinds of stuffs. So then the main thing or the main purpose of logistic regression is not only predicting the class, not only predicting yes or no, not only predicting pregnant, not pregnant, but logistic regression can also predict or measure the probability of being yes or the probability of being no. So that is the good thing about logistic regression, and we will see it also on the way how it works. Okay, but in what situation or conditions can we use logistic regressions? First, if the target variable or the target field in your data is binary, yes or no, or true or false, then you can use immediately logistic regression. There can be another machine learning, but it's better to use logistic regressions. Second, if you want or if you need, the probability of your prediction. So when you predict yes, And if you wanted to know the probability of yes, then you can use logistic regression. Also, if your data is linearly separable, that one side is clustered to no, if you want the other class to be clustered as yes, and if it is linearly separable, then you can use also logistic regressions. Another important situation that you can use logistic regression is if you need to understand the impact of a feature. That means when you model, when you make model, when you have the logistic regression, so looking at for the parameters or the coefficients, you can know which independent variable has impact on the dependent variable. So those features with higher coefficients has higher impact on the dependent variable. So logistic regression helps you to predict or to know, to understand the impact of a feature. So building a model for customer churn. So for example, as I told you, if these are your independent variable for a given data set, so these are the independent variables, and you can see also the dependent variable. So if I give for the independent variable x, for the dependent variable y, then you can start also building your model, and we will see this also on the in the code. These are the mathematical expressions. So taking x, the data variable, which is m dimension, the features with the records n. So our x is, it is a space of real number with m dimensions, the features, and also n records. And as you can see, y is only an element of two numbers, that is 0 and 1. So y hat can predicate the class of the customer is 1 given its features x. So y hat gives you the class of a customer with a given feature of x. So if you have the probability of class 1 to predicate, the probability of class 0 is simply mathematics, like 1 minus the probability of class 1 gives you the probability of class 0. So the mathematical expression in of logistic regression, this is if you are interested in mathematics, or if you wanted to know behind the logistic regression with Python, it is good to know the mathematical expressions or the logic behind the logic behind the model in Python. Otherwise, it's not necessary to have a mathematical such deep mathematical knowledge to run the code. So if you recall linear regression with a given value of y, and also coefficients like theta 0, theta 1, also theta 2, it goes like that, and also with a variable name like x1, x2. So this is the linear regression, a simple form. Now with the linear regression, you predicate only you predicate only the 0 or 1. But with sigmoid function, you predicate the probability. You predicate the probability of the class 1 or 0. That is the advantage of sigmoid function. Here, this y, that y hat predicates directly the class, whether it is 0 or 1. For example, if your function or your y is less than 0.5, then it is class 0. If your function or y is greater than or equal to 5, then it predicates like 1. But with sigmoid function, it gives you the probability of being class 1 or being class 0. That is the advantage of sigmoid function or logistic function. Okay, now we will proceed to our data set. It is customer churn with logistic regression. So teleco customer churn. So churn means, if you see in the dictionary what churn means, churn is a container or a machine in which milk is agitated to produce butter. So customer churn means those customers who are stopping or leaving the company. That is the customer churn. So with logistic regression, you are able to predicate who customer is leaving the company or who customers staying in the company. So we will predicate the customers who are leaving and who are also staying in a company. About the data set. So we will use a telecommunication data set for predicting customer churn. So we will first import the required libraries to load the teleco churn data. So I have here written already the necessary libraries like pandas for the data manipulation, because you may obtain your data as CSV file and it is unstructured. So through pandas, you can manipulate your libraries, your data. And also I have imported PayLab, NumPy, CPy, sklearn, Matplotlib, all different libraries which are helpful to load the teleco churn data. So I will run. So it is taking time to run. Yeah. Okay. Now to load the file, I have given the variable name for my data frame churn_df. Writing the pandas pd.read_csv and also the file path and the file name. The file path or the directory is found in my downloads, and also the file name is churn data.csv. So I will load it. So it's already loaded. So if I want to see my data frame, I use churn df.head. So by default, it gives me the first 5 rows. So by using churn df.head, I'm getting the first 5 heads. So we can see that the CSV file or our data, that is telecom, has tenure, age, address, income, etc. So, and also if I want to know the shape of my data is churndf.shape. So I have 200 rows and 28 columns. So in this data, all the rows, each row represents each customer. Okay, for example, row 0 indicates for a customer, and also row n also represents for a customer, for another customer. So this data set gives me information about the behavior, the age, and also what they signed up for. So like the age of the customer, their address, their income, and the other things, and also how long they stay in the company. All this information I can get from my data set. So now I will, if I want to know the information for each columnist, then I can run this one. Then I get that tenure is a non-float. It is a float object. I can see that all my all the columns are float. I can see them. Okay. If I want the describe helps us to know the mean and also the maximum values for the data set in each column. For example, in tenure we have 200 rows, so the minimum value is 35, and the variation, the standard variation, the minimum, the maximum in each column, if that is useful for for data exploratory. So data pre-processing and selection. But I can use, if there were categories, now I can see that all the columns, they are float. If there were categorical in my column, I would use this formula, describe include equal to all. But since I have no categorical object in my column, I don't need to use this formula. Now I'm checking if I have any null values. Otherwise, I can deal with the missing values. So I can see that I have no missing values. So the data is clean. I don't need to deal with any missing values. So before you proceed, before you model, you have to check the missing values. And I have checked the missing values, and there is no missing values. To check the missing values, what you can use is churn df.isna.sum. Okay, now I will select some features or independent variables for the modeling. Now I selected tenure, 7 features like tenure, age, address, income, employee, equip, call card, wireless, and also the targeted variable, which is churn. So now I will create a new data frame with the same variable name, churn df. So if I run, then I have created a new data frame with the same variable name, churn df. And I will run the new data frame which I created. Here I have got these features. So when you want to create a new data frame, you can use the formula that I used, churn df with the brackets. Now, as you can see, the target variable is still in float, and it must be also integer because it is required by scikit-learn algorithm. So I converted it into integer type using churn df dot as type and inside integer. So convert it into integer. So I converted it into integer. Now if I run the new head, so and you see the difference here. We have float for the churn, for the target variable, and when it changed to integer, so we have now 1 and 0 integers. It's not float. So if you check the new data frame, the shape, so you have 200 rows and 10 columns. Now let's define the x values and also the y values for our data set. So I take tenure, age, address, income, it employ and equip as X values or as independent variables or features. So, and then I convert them into array, because as you can see that the data type for tenure for age, it is as a pandas series. So for scientific competition, for mathematical competition, you have to convert it into NumPy, into array. So to get an array values, we must import also a NumPy library. So I have already imported my NumPy library using import NumPy NP in the first cell. So if I run X, so the features of X, they are converted into NumPy, and if you wanted to check them, we have now, if you want to check the first 5 rows, so it's now array. It's not now a pandas series form. It's now converted into scientific, which is comfortable for scientific competition. Now I convert also churn, which was integer. Now it is converted into array. So it's now array form with 1, 1, 0, 0, and it continues like that. Now from scikit-learn import pre-processing. So now we are standardizing our X values. There can be also great X values. So it is reduced so as the standard variation is small between the variables of X. So if you run that one, now you can see that it is changed into it is transformed into standardized form. Now we will train and test datasets. So split dataset into train and test set. We will select 20% as test size and 80% as training. So importing sklearn.module selection import train test split. Now we will split our data into train and also test. So X train, X test, Y train, Y test with a train test split model. X, Y, use test size 0.2. 0.2 means use from the data set 20% as a test and 80% as a training. Random set equal to 4. That means randomly select every 4. Okay, then if you print your train shape and also your X shape for train, X train dot shape and Y train dot shape, X test shape and Y test shape, so you will get this value. So you have 160 train set and also 40 for test set. So you are splitting your data into 2 parts for training and test, because if you train your model on the same data set, there may be a problem for out of sample. So it's good to train your model using train split method. Now building our model using logistic regression. From scikit-learn.linear model, import logistic regression. So giving a variable name LR for the model logistic regression and inserting significant number variables like C solver dot fit, also X train and Y train. So I don't have deep knowledge actually for the linear solvers. Then you have built a logistic regression. Now using the logistic regression LR, you are going to predicate your X test. So predicating your X test, now you have these variables. So your model doesn't know the data set of X test. So you train, that means you get your coefficients from training model, you get your coefficients and you are checking whether your model is correct or not. So you predicate and you got these results 0, 0 and 1, 1. It is binary between 0 and 1. Now, predicating probability. As I told you, logistic regression doesn't predicate only the class 0 or 1. Logistic regression, you can also predicate the probability being class 1 or 0. So this gives us about the being class 0 and being class 1. Now, evaluation for our model. So how much is our model correct? How much percent is our model correct? So if you want to check or the accuracy or to evaluate the accuracy of your model, you can use different kinds like Jacquard conversion matrices, F1 score. There are different kinds of metrics. Now I select, I use the Jacquard index. So the Jacquard index can be defined as the size of the intersection divided by the size of the union of the two set labels. So from scalar dot matrix, import Jacquard similarity score and evaluating them. So you have 0.75. That means our prediction are almost 75% correct. So our prediction is 75% correct. That is, we have identified 75% of the churn rate correctly. So you are comparing the predicator value y hat with the test, that the y test is the actual values. So comparing the predicator values y hat with the test values, so you are 75% correct with your model. 75% with your model. Now, if you wanted to increase your percentage of accuracy, you may change here in the solver. If you change like SG, there are different kinds of solvers, then your accuracy may increase. Also, if you use more independent features, for example, I selected 7 independent features. So if you use more independent features which have good correlation with the dependent variables, then you can increase also your accuracy. And also the log loss, this is also a method of evaluation for your model of probability. So from scalar dot matrix, import log loss. So log loss will compare the probability of the class being in class 1 and also with the actual values. So you have 0.6, the log loss. The log loss is used for evaluating the accuracy of your probability. So 0.6 is also okay. It's also okay, but it may need to be increased. So thank you for listening to me. This was all my presentation, and yeah, I tried my best to prepare for this. And yeah, I'm not an expert, but if you have any question, then I may try to answer your questions as well. So thank you for listening to me.
Thank you, Semere, and thank you everyone for joining us. If you have any questions, please unmute your mics or leave them in the chat, and Semere can answer them.
I have a question. Thanks for your talk. First thing first, it was a nice talk. Yes. I'm
Thank you.
more curious about data science as a role. So, as far as I understood, the whole job is to import the right library and use the right method. So, is it correct, or you actually do some research, read some, I don't know, I would say some articles, what's popping right now and stuff like that? Thanks.
Sorry, is that a question or?
Yeah, my question is, so in actual work, day-to-day work, are you just importing a right library and use right, I know, method for evaluation of the features, but are you actually doing some sort of research in the, I know,
Yeah, for example, if I correctly understand your question, yes, you have to import right libraries. For example, if you want to manipulate unstructured data, you have to import a pandas library. And for scientific competition, you have to use NumPy. Also, for modeling, yeah, you have to import also sklearn. For accuracies, you can use Jacquard indexes or confusion matrices. So yeah, for if someone uses Jacquard index, if I agree with Jacquard, I can agree with Jacquard index. So did I answer correctly your question or?
yeah, I'm asking more about day-to-day work. For example, like, do you have some challenging task and you're trying to tackle this problem with different scientific approaches, or you just know, okay, this problem
Yeah.
I can use, for example, linear regression or logistic curve, whatever. So
Yeah,
that's about it.
yeah, exactly. I have already said in the beginning that if you wanted to predicate for categorical variables, you have to use logistic regression, not linear regression. So if day to day, if I am challenged, then have what kind of method or modeling I should use for categorical prediction? I should use logistic regression, not linear regression. You can use also another regressions other than logistic regressions, but you cannot use linear regression for categorical variables, for example. So yes, if I have to use the right method for predicting or for working.
Semere, would you say that how much of your day-to-day work with data projects, when you're working on data projects, how much time or effort do you put into figuring out what is the right method, what is the right data set, what is the right process? I think that's where, if I understand correctly, I think that's where the curiosity, the question is, the curiosity about what does the day-to-day look like when you're working with data, and how do you make those decisions?
Okay, yeah. If I'm encountered that I do not know or if challenges me, yes, of course. I have to ask someone or I have to search on Google. Yeah. So, for example, we have worked like on UVF data projects. Yeah, and then we were searching. To use the right method. So yes, we search. We spend time or we ask people who are above us, and also we search also. Yeah, we spend the time to select the right.
And what is the process of estimation for research? I don't know. In the terms of agile development, how you can estimate a research activities for teachers? What you I don't know.
So I can give some perspective on that. If estimation, like anything else, any other development project, whether it's DevOps or machine learning ops, is a dark art, and it comes through looking at the data. So if you are working, if you are receiving a fairly unstructured project topic, for example, a research question, then you can estimate that you will need to spend some significant hours and significant time into figuring out not only what is the domain and the context of the question, but which data sets can you access, or are you going to be able to use, or will be useful. It is, if you don't have anything to go by in terms of a previous project that you can look at your estimations, then a lot of what you can do to help you get to that point for the future is to be doing it, breaking everything down into very definitive iterations and say, okay, I am going to start this project and I am going to allocate, in a week of 40 hours, for example, I'm going to allocate 8 hours to finding out, to doing research on the existing body of documentation that exists, or the existing documents. And then from there, I will allocate how many hours I need to use towards finding the data sets, or will I need to collect the data myself? And looking at previous projects is your best place to start. But if you haven't had that already, then starting by making a schedule and sticking to it, and if you go over it, then you just need to include that in your estimates so that you know for your next project. It depends on it all depends on the size and the scope of what you're trying to do. But it's not that much different from estimating for an agile project or for software development.
Yeah, okay, thanks.
Yeah, so what we follow in the lab is when we assign them a project, we say, okay, you have 3 weeks, for example, from start to finish, to here's your raw data sets, or here's where the data sets that you can access, and here's our expectation of what we want as a deliverable at the end of that 3 weeks. And then their team has to form together and do their own project planning and do their allocation and break down their work across that team, knowing that they have stakeholders that they have to deliver, a working model and an analysis and a report by the end of the 3 weeks.
Yeah.
I may have also another question for the one who asked the question. I think he's Max, yes?
Yeah.
My question is, I think from your question, it makes me something like, if you can make the question like specific, like especially for the libraries that you ask him, are you making some research on the libraries? Is that the right libraries that you use for the dataset? So maybe I feel like you have some experience with this library. So which ones makes you worries, in order to make for me clear, on which libraries are you specifically asking him that they are the right libraries, or whether they need some research on? That is for Max, sorry.
Oh, so sorry, I missed that. Okay, thanks.
Is there any other questions?
Yeah,
Sorry.
there are more questions in the chat, Semi. Someone is asking, are you going to share the data set on the notebook or push it to somewhere? I don't know what is it. So they can clone. Do you see the chat?
Okay, are you going to share the dataset in notebook or push it to GitHub also we can clone it? Okay, then, okay, I will do. Yeah, I can do it, but not now. Later, maybe. I cannot promise it now, but maybe in the future I will do it. Okay.
And Tolga, is she still here? She has 2 questions. If you can ask. Oh, her mic is off.
Yeah,
Okay,
she said I have 2 questions. Yeah.
She will write them in the chat.
So the accuracy seems pretty good, but on the other hand, I don't know about the balance of the dataset. So the accuracy, it starts. I mean, if the number of the retained are way higher than churn ones, the number of retained are higher than, then the pressure will be pretty small. Okay, have you handled this problem? Yeah, maybe if I understand correctly, your answer may be beyond the scope what I told you, what I presented today. Yeah, I think confusion matrix is a good way to balance on which side. For example, from our data set, we have 40 outputs. So from the 40 outputs, we can see that 24 of them, they are zeros, I think so, and 6 of them, and 16 of them, they are ones. So confusion matrix solves like from the 24 that I predicate 0, confusion matrix can tell me out of 24 that you predicate 0, you are correct 23, and 1 is you are wrong. So yes, confusion matrix can solve this as, but I'm still digging out how can I work with confusion matrix. But I have a little hint about the confusion matrix can answer your question. Did I say right for you, Tolga? Hello, Tolga. Did you hear me well? Okay. Yeah, she says yes, thank you, but it was not exactly my question. Okay. Yeah, I tried to understand your question. Yeah.
Tolga, you need to give a permission to activate your mic.
Yeah. Okay, she's telling to skip for the next question. I write meanwhile. Okay. Yeah. So if anyone has also a question other than Tolga, she is, yeah, she said if someone else has a question, he may ask.
Semere, if
Yeah.
I understand your question, maybe like the balance of your data set, like when you are testing and training the data set, what is exactly the balance? Which how much percent are you giving, like 80 or 70% for training and 30% for? So is that good, or is that the right balance for the data set?
Yeah, I think if that is the question, I think Caroline answered it correctly. That I take, if you take a large percent, like 80% of your data for training, and a small percent, like 20% for testing, then you are protecting the overfitting. But if you take the whole data set for training, then your model cannot work good for out of sample. So to balance it, so it is good to take like 80% or large enough for the training set. I think Caroline answered correctly if that is her question, what Tekla said.
I have a question. How understand what you mined enough data for analysis to go further with the trainings and stuff. What is a decision when, okay, so I collected like 10,000 entities or 1,000, or how to understand what it's enough for analysis?
Yeah. You mean originally when you are collecting the data?
Yes, yeah,
Data?
for training, for example, 100 records, it's enough, or 1,000 or 10,000.
Yeah, that is, for example, we can speak like percentage, I think so. You mean for the training, the model, Max?
Like in general, not especially for this case.
Yeah. Yes, of course. For example, for training the model, it is better to take like a big enough or like 80% for training your model.
No, I'm not asking about percentage. I'm asking about actual records in CSV file for like 10 or 1,000 or 10,000.
Yeah, I don't have enough knowledge actually for that, but I believe that if it is much information, then you may get a precise result. I think so. So the more your information is, the more your accuracy can be better. I think so.
But you can end up with overfitting your network, or how it works. I don't know. I'm not a data scientist, sorry.
Yeah. Okay. Yeah. So that is of course. Then of course. So Caroline also said that depend on your sample size actually. That the more your information or the more your records and your columns, then you get a better precise. But for example, if the independent variables or the features has directly correlation or positive correlation with your result, then it's good to select the features that has a positive correlation with your dependent variables. Yeah. Yeah.
Thanks.
Okay, you're welcome. So I think Tolga has written something. So scientifically, the notebook seems very successful. On the other hand, a price is to estimate most churn in people from BS with accuracies. But the thief is approach reduced accuracy. Yeah, Tolga. Yes, of course. Yeah, I know that I have to do a lot. My task was just to training the model, and I use also the Jacquard index. But you can continue also like confusion matrix, F1 score. Then you can calculate also the true positive, the true negative, like that. I think that can help us a lot, but I do not go further. But maybe I can develop more about what I have worked, but I have a little knowledge about what you are talking about. I know the confusion matrices and other things. Then it can increase also. Then you can measure correctly more your model, your accuracy, the accuracy of your model. Yeah, thank you. Thank you so much also for your question. They are really edifying questions, and they are also in my mind.
Maybe also Semere on that question, can the features that you most likely choosing to predict or for making the accuracy higher, it's based on the correlation of the features with the dependent variable. Can that increase your, accuracy? Can that maybe also increase?
Yeah. Yeah. For the accuracy, yes, of course there are more. Yeah, if you select, for example, more features, the features, for example, I select 7 features, but if there are another features that has a good correlation with your dependent variable, and if you select like 14 or 15 features, then this will increase also the accuracy of your model. So the more the number of your features, and if your features has also positive correlation with your dependent variable, then you may get also a more accuracy. Yeah, do you understand me, Clear?
Yeah, okay, thank you.
Yeah, you're welcome.
All right. I think those were the questions. Thank you, Semere.
Okay, you're welcome.
And thank you everyone for joining today's session.
Yeah.
If you want to attend more sessions like this, make sure to become a member of our meetup group so you don't miss out. If you want to do presentations yourself on a topic related to data, then contact us and we will provide this platform to you. I hope that you enjoy the rest of the week. And we hope to see you again.
Okay, thank you everybody also for your question, and have a nice time.
Thank you, Semere.
Yeah.
Thanks.